Hello everybody and welcome to our Master of Advanced Engineering webinar that we're having for you tonight. We're very excited to be here with you. We will just check that you can all hear us. So throughout the presentation we might ask you to raise your hand. So please raise your hand now by clicking the raise hand icon on the webinar panel so that we can see that you're here. Thank you. You can also submit text questions via the Q&A icon, and that once that's clicked, it'll open a message pane for you. Now, presenters will try to answer the questions for you here, and if we can't, then we can take the queries offline and get back to you at a later date. So my name's Helen O'Keefe, and I work in the student recruitment team here in the Faculty of Engineering. We have with us tonight Professor Nikhil Medhekar, who is the course director for the Master of Advanced Engineering, and we also have Rowan, who is one of our students in the Advanced Engineering course. So what we thought we'd do tonight is just run through an overview of the course. So Nikhil will just run through why you might consider doing the course, the content, the sorts of subjects that you'll study, the sorts of outcomes from the course, and then you're welcome to send in any questions and we'll go through those, and then after that we will have Rowan have a chat about his experience as a student with us and what he's learning as he goes through, just about to finish his first year of the two-year program. So we'll start off with our presentation. So over to you, Nikhil.
All right, so it's great to have you here. Unfortunately, I cannot see you, but I'm assuming that you are sitting right in front of me and try to tell you how fantastic this program is. So this program is called a Master of Advanced Engineering, and the reason we like to call it as an advanced program because it is meant to advance your career and to make you a leader in your chosen fields. So what that means is that this is a unique program compared to all our other programs in Australia or even abroad, that it gives you a depth of technical expertise that is unparalleled, that you do not see that such expertise and such depth in other programs. You get to work with the global leaders. So what that means is that these units and these classes and the laboratories and the workshops are taught by teachers who are truly exceptionally qualified in teaching those subjects, and they are recognized world over. You get to develop your networking skills with fellow students, not just doing the program, but also those are not done with the program, with the lecturers and tutors and professors. And we also have two essential units, small courses we call here in Australia as units, that teach you specifically leadership and the skills that are essential for any engineer, irrespective of your background, that are essential to get you up to this speed, and that are essential to be a leader in your field so that you can start making strategic, important business decisions. So we have very briefly 7 core specializations: standard electrical engineering, material science and engineering, we have mechanical engineering, chemical engineering. So Ron here is going to talk more about his experiences with chemical engineering. We have 3 specializations that are within the umbrella of civil engineering. We have water, transport, and importantly, the infrastructure engineering. So these programs are specializations. So if you have done your undergraduate degrees in any of the related programs, if you do this, if you continue with these programs, you can be sure that you will get a very high level expertise in your field. In addition to that, we have 3 new interdisciplinary specializations, and essentially what these specializations are, these are outward-looking industry sector specializations. So you look at the renewable and energy, sustainable energy engineering. So it doesn't matter what kind of engineer you are, you're a chemical engineer, material science engineer, mechanical engineer. If you have interest in working in energy-related industry, so it could be petroleum, hydropower, renewable industry, or even the traditional coal mining type industry, all of them are being impacted by the changes in the renewable energy sector. Even the traditional energy companies are impacted because of the changes in the renewable energies, right? So this particular specialization teaches you all about that, how the total economy is changing, how the engineering is changing because of the energy related problems and how we address them. Right? Second example is medical engineering. So this is also an example where students and engineers from different backgrounds, may they be mechanical engineers, electrical engineers, they have to, for example, they have to come together and then develop solutions, develop technology solutions that are sorry about that. So develop technological solutions that are essentially meant to improve the health of humans. So for example, wearable sensors, bionic eye technologies. We also teach translation of medical technologies. For example, whatever you learn and develop in the laboratories, how do you translate that to the practical field? So there are also rules and regulations surrounding that. How do you get around them? How do you address them? So this is an exciting, really area of interdisciplinary specialization. Next one. And starting this year, we also have begun to offer additive manufacturing, so which I'm sure you may have heard about it. So it's basically 3D printing, not just polymers and soft materials, but we also have capability of 3D printing real, aero and mechanical industrial components. So this is very serious. We also have we also cover biological applications using 3D printing. For example, we now have the ability to 3D print any tissues or even in some cases some biological appendages that are specifically designed to a particular patient's human bodies, right? So that this is an advantage, and we believe that this is going to be a really emerging field in manufacturing sector or even in any sector, especially in medical sector too. It's going to be emerging. So how does our program look like? So this is an example of a 1-year program. 1-year program is divided into 2 semesters. Each semester has 4 courses. Here we call courses as units, so essentially the same. Out of those 8 courses, we have 2 of them essentially common core, so which everyone enrolled does that. One of that being engineering, advanced engineering analysis, which teaches you how to analyze data, how to visualize data, and how to use data to make informed engineering business decisions. The second common core unit or course is basically on entrepreneurship. It teaches you basics and fundamentals of engineering entrepreneurship, a little bit of finance, a little bit of venture capital raising, a little bit of how do you take the ideas from the laboratories to the marketplace and what are the obstacles in that process and how do you get around them. In addition to that, you will then have 4 discipline core units that are essentially meant to give you a depth of expertise in your field. And 2 enhancement elective. 1 enhancement elective is to give you a little bit of breadth. So for example, many of our students do this enhancement elective in business and economics related subjects because that's what they are interested in. And the last one is a research unit, which allows you to do research on one of the topics of very important common problems. Okay, so this is a general structure for 1-year program. For 2-year program, the structure is slightly different. You still have discipline core units, you still have entrepreneurship, work integrated learning, you still have enhancement electives, but you have now technical electives. They are basically meant to give you a bit of foundation, as well as the main difference between 2-year and 1-year program is the project, the engineering design project and engineering research project. These are meant to give you a very good experience in multidisciplinary teams of working on a problem that's an engineering problem that requires an engineering solution from a team of engineers that are essentially from different backgrounds. So what that means is that we have these projects running in teams where a student from chemical engineering background will be working in team with mechanical materials and even electrical engineering. So they get to learn from each other, but the common goal that they work towards is to develop those engineering solutions for this. So this is a very exciting, these two project units are quite exciting. All right, so simple entry requirements, and if you have any questions about this later on, you can always shoot an email. So 70% equivalent for 1-year program, and for 2-year program, 65% equivalent. And we also allow for someone who has done some relevant industry experience to enter this program a little bit easily compared to those who do not have experience. We have fantastic teaching facilities. Our teaching facilities are especially world-renowned libraries and laboratories and wind tunnels, as well as the advanced data visualization facilities. Our teaching philosophy in particular is very hands-on. So as you can see in the pictures, much less teaching is done via standard lectures, but more is done via more interactive demonstrations and tutoring and basically having students work through their material in groups. So as you can see in the first picture. All right, so that's a very brief presentation, but I'm sure that if you have any questions, please send us an email and we can continue this webinar further.
Thank you for that. Please send the questions through and we will endeavour to answer them. Can I just ask you, Nikhil, as a teacher in this program, what is the best thing about it for you as somebody who's teaching it and has helped develop the program?
So we have developed this program basically in order to give a very unique set of masters, really. So if you could look around Australian or even overseas masters, they tend to not give the technical expertise and technical depth, but we have developed this program with the technical depth as the main principle driving this program. So if you ask me just in 2 words, what is the key differentiator of this program, I would say it's the technical depth. And second, and then the reason that we would really love to teach this program is basically that the bright students that are highly motivated. It gives basically the motivated the student is, it's easier and more fun to teach.
Mm-hmm. And would you say that most people come straight through from an undergrad, or some have been out to work, or it's a bit of a mix?
We have a bit of mix, though a large number of students also come from a straight undergrad.
Fantastic. All right, well, we might go over to Rowan. Rowan, do you want to start off just talking to us a little bit about what your educational background was and work experience and how you found your way into this course?
So I completed my chemical engineering, like Bachelor in Chemical Engineering in 2016 in India. After that, I spent 8 months looking for a job in chemical engineering field, but then like the particular field that I wanted to get into was energy technology. Like it could be either oil and gas or renewable energy, but then for me to get that job in India was quite difficult because there was not enough industries over there, and the industries which were there was kind of saturated. So, and upon that, like there was I was not completely well-rounded. There was a lot of knowledge that I didn't have, which they required of me. So in that time, like I didn't think about doing my postgrad immediately. I thought I'd work a while before starting my postgrad. So I joined the company. I joined Amazon. I was working over there, but in 6 months I realized that was not the job for me, and then I realized that I needed to focus on my higher studies.
What made you feel it wasn't for you?
I had done my engineering, so I know like what I had learned.
Yep.
But then what the kind of knowledge I was utilizing, I felt I was the capabilities I have, I wasn't utilizing like my complete potential. So I left. I applied for my postgrads in a few colleges, and Monash was one of my top picks because in chemical engineering it is the highest rated in Australia. And apart from that, there are a few researchers who are
we are highest rated in engineering in Australia.
Yeah.
Not just chemical.
So in like there are a few researchers, like professors in chemical engineering who do a lot of research on renewable energy, like solar cells and all of those. Those are the fields that I was interested in. So it also furthered my chance to work with them. That's why I kind of chose Monash to continue my studies. And right now I'm almost complete. I've almost finished my first year, and it's been pretty interesting because it's a mix of chemical engineering subjects as well as you mentioned, like two enhancement units. So in those enhancement units, I can choose any unit from other disciplines. And I was focused on mostly improving my engineering knowledge rather than trying to be like well-rounded, like as a commercial student as well as engineering. But I just wanted to improve my engineering knowledge. So I've taken subjects in the electrical and some material science field, like advanced photovoltaics last semester, and this semester it's smart grids. So they are quite challenging because I'm a chemical engineering student and that's my background. But the amount of resources the university provides, I wouldn't say it makes it easy. It makes it like it's more attainable. I still need to put my effort, but yeah.
Fantastic. And have you been involved in other things like outside clubs or anything?
Yeah. So since I was again interested in renewable energy, I joined the environmental engineering club in Monash. So they have had a lot of industrial meetups, and I've got a chance to speak to a lot of people in the Australian workforce. Apart from that, I was also part of SMOOS, which is the Monash University Chemical Engineering Society. That society is like something that it's for a master's student, I wouldn't say it's the main one to be, but then it does provide a lot of opportunities to meet with alumni in chemical engineering field. Yeah, those are the only two groups I'm in as of now, though.
That's good. Now, please feel free to send some questions through, or we can keep on asking you questions ourselves. So you'll be going on a work placement. Mm-hmm. And how do you go about organising that? Do we help? Do you have to work it out yourself?
So once you join Monash, after you complete your first semester, you need to ensure that you have a 70% WAM. That's basically like your average marks in all 4 subjects from your first semester have to be above 70%. And once you maintain that, the Monash is, I don't know who they are, but like they just reach out to you and they help you. Like there's an interview process. It is quite a challenging interview process because it's you're placed in a very good environment that'll help you learn a lot.
Yep.
So you go through that, and if you get selected, you get an opportunity to work in this one company as part of your course. So yeah, that's something that's there for me next year.
Mm-hmm. Looking forward to it.
Yeah.
Alrighty. Now, the other thing I was going to ask you was, what's been the best thing about doing the program?
So last semester I was kind of blown away because there was one subject I remember, it was called sustainable processing. I was attending the lectures and everything properly for that, and what blew me away was the professor. He was so well, like he wasn't just teaching me what's in the books. He was like giving me actual live examples because he was a person who worked in this chemical engineering field for 25 years. And then he's come to teach after that. So the amount of knowledge you can gain from him, like just sitting in those 12 lectures, it was 2-hour lectures per week. So in those 12 lectures, I had gained so much knowledge. It kind of blew me away and I even asked him like, what made you come into chemical engineering as a teacher? Because he's really well knowledge. He really doesn't need to be a teacher to do anything like. So he was like just talking about how he wanted to share his knowledge and stuff. But that was one of the subjects that one subject, I feel all of chemical engineering, what I did in 4 years of undergrad, this one subject, it kind of made up for all of that, which I was lacking.
Okay, so it just sort of brought it all together for you. Alrighty, let's see if we've got some questions. If I could make it work, that would help.
Do you want me to tell you the questions? There's one from Ravi Helen.
Oh, yes.
Who is wondering if the course is a type of research master's or if it can be developed towards a research master's and then a PhD?
It's a coursework master's, but there is some opportunity for the research through the research projects and research units. But it is mainly a coursework master's.
Okay. And we've got one asking about chartered status as well. Can you explain?
So chartered status is not something that Monash University or any university is equipped to give. Chartered status is basically given out by Engineers Australia, and it really depends on what kind of experience that you have, how long the experience you have. But we believe that if you have 4 to 5 years of basic experience in working with the industry, you can go and get charter status pretty fast.
Okay, thank you. We might finish up because we haven't got any other questions. Was there anything else that you wanted to add to that? And what advice would you give for people, Rowan, who are thinking about coming into the course? What would be your one piece of mind-blowing advice for those people?
Like, if you're coming for the course and you're actually trying to learn, it would be a good course. If you're just trying to get a degree, it's going to be much more challenging because it's not something that the university actually makes you work for your degree. Because what I was told was that if you actually work for something, like if you struggle, that's when you learn.
Yep.
If it's given to you easily, there's nothing that you gain from it. So I wouldn't say it is impossible to do this degree. It is very much attainable. It's easy. It's not easy. It is very possible to get good grades in this degree, but you have to put your effort. Without that, it's going to be very difficult.
Fair enough. Good advice. Actually, there is another question here about the split between international and domestic students.
I think you have the knowledge on that.
Yeah, for sure. So largely our cohort at the moment is an international cohort. Yeah, we have great diversity. I don't think I'm going to make it into camera, am I? It's just a silent voice coming from the end. Largely an international cohort, but a very diverse international cohort. So, and growing on the domestic scene. A lot more of our domestic students are doing a vertical double, so they are joining the undergraduate course and moving directly into the postgraduate course as one package. That's becoming very popular. Yeah. Would you agree? Quite a diverse cohort at the moment. Yeah.
There's a lot of international students.
I was interested in how you're finding Australia and your transition into the country.
It's not been that hard.
Yeah.
Yeah. The only problem that I had was drinking tap water. Yeah, because there's still the mental block about tap water. Yeah. Apart from that, it's been fine because honestly, like there's like a lot of Indians over here, so I don't feel that much away from home. Yeah.
You can drink out of the garden hose here, can't you?
Might take me some time to reach there. I'm still dealing with the tap water.
I was also interested in why you chose Monash.
As I said, I was researching all the research that Monash was doing. I know I wasn't doing a research degree, I was doing a coursework, but then I know in my final 2 years, I have to do 2 projects, and those will be supervised by lecturers from the chemical engineering department or other departments, depends on your interest. You need to reach out to them. So if I had to do that, I wanted to work under people who are really well versed in a certain field that I was interested in. And then there were a few professors in the Monash chemical engineering field that were researching into this one. So, I mean, I'm doing chemical engineering, but I want to get into the energy sector. So renewable energy is something that I want to go into. So photovoltaic is a huge part of renewable energy. And there's a couple of professors in Monash that are, I'd say not head, but they're very well known in that industry.
Julie, can you see any more questions that I can't see?
There's just one about extracurricular activities that, what do you do outside of your study at Monash?
There are a lot. But then if you want to make, finding the balance of maintaining your studies and doing that extracurricular is going to be a challenge. But there are a lot of extracurriculars because there's a group of people out here, we play football regularly over the weekends. our football, which is like not the Aussie football. Yeah, soccer. Yeah,
Real football.
yeah. And there are other this one clubs as well. Like I remember in the first month I joined, there was a huge events where a lot of clubs were there, and you could go and see whichever clubs interest you. You could join them. I know a lot of people who are international students join the outdoor activities club because it's a fun way to explore Australia. Yeah.
Alrighty, so if there's no more questions, we might finish it up there. So we will be sending out this presentation to everybody who's tuned in, and it's got the contact details. But if you have any questions later on and you're looking to find out the answers, you can dial 1800 Monash, which is 1800 666 274, and that's whether you're international or it's or Australian. It's a free call. Or if you are an Australian student, you can email future@monash or study@monash.edu, and all of that information is on that presentation that you can send through. So I would like to thank very much Nikhil. I'd like to thank you, Rowan, for coming on. I'd like to thank you, Alyssa, for popping in, and to all the technical staff here who've helped out.
Thanks, Helen.
So thank you very much for tuning in.
Thank you.
Thanks. Bye-bye.
Thank you.
Thank you.
Thank you.